Okay, so now we're going to go through the notes, and I'm going to make sure you guys have them all filled in. We will talk about these notes again, when we meet on Monday. I'll be there on Monday. But I do need you guys to have them filled in, so that is what I'm expecting you to do right now, okay? And this is the part where if you are being disruptive, being on your cell phone, talking, you will be sent out, okay? All right, so another thing to keep in mind when I'm teaching you in person, a lot of the times you guys will, have comments about what I'm teaching. Remember that I'm a talking head in the front of the room and I can't hear what you're saying. So if you're talking, even if you're on task, like asking a question about or making a comment about what I'm talking about, remember I can't hear you. And that means that I'm going to keep talking and you're going to be talking over me when you're making those comments. So do not talk over me during this video, okay? If you do that, and other people can't hear me, then you'll miss something, and then you'll be like, oh, wait, what was number whatever? So anyway, so you guys all have your notes out in front of you and something to write with. So just to recap a little bit, we talked about, so we are on page 3. We might be past that, but just recapping a little bit. We were talking about carbon and organic molecules. So remember that a molecule is not organic unless it's synthesized by something that's alive, okay? But not just synthesized once. Like we can synthesize carbon dioxide, but carbon dioxide is not organic because carbon dioxide is found in other places on the earth, okay? And it doesn't only exist here because living things synthesize it. Okay, so that's why it's not organic. Organic molecules are molecules like proteins and lipids and carbs, because those are things that if you find them, you know that they were produced by a living thing. All right. So we talked about that. Then we talked about carbon chains, how carbon atoms like to form 4 bonds. And because of that, they can form these long networks and long chains. And they're really important to life because of that. So a lot of these molecules that we're talking about, these biomolecules, the protein, the lipid, the carb, the nucleic acid, they have a ton of carbon in them. Okay, not carbohydrate, have a ton of carbon in them. Then we talked about polymers and monomers and polymerization. Polymer is a huge repeating molecule. So it looks really big from the outside, but it's really just made of the same subunit repeating over and over and over. And that one part that repeats over and over and over is called its monomer. Okay. And we're going to be talking about in our biomolecules, there are 3 that are polymers because they have monomers. They're made of one part that repeats over and over and over. All right. So I believe we left off on number 9. Most of you got to it. It says, number 9, what are the 4 major groups of biological molecules? So you guys should have carbohydrates, nucleic acids, lipids, and proteins. Yeah, proteins. Okay. So now we're all on page 4. Some of you got a couple in and some of you didn't get to this page. So number 10 says carbohydrates are compounds made of carbon, hydrogen, and oxygen atoms. So remember in the video, there was like that chomp. They were talking about the different atoms that are in these molecules that we are learning about. All right, so the CHO is the carbon, hydrogen, oxygen. It's in all of them. 11 on your paper, carbohydrates are our main source of energy. Okay. 12, a carbohydrate is a polymer, which you remember it's a generic term for a big molecule that repeats over and over. 13, the repeating parts of a complex carbohydrate are called glucose molecules, I had you put. But also, I want to point out that glucose isn't the only thing that makes up. It's not, excuse me. It's not the only simple carbohydrate. It's just like the main one that we talk about in living environment. And it's a really, really important molecule for life. Glucose is. And again, that's a simple sugar. At this point, we should have 10, 11, 12, and 13 filled out. Okay. 14 says, therefore, glucose is said to be the building block of complex carbohydrates. Then 15, what is the main way to identify a carbohydrate molecule written in its structural formula? So I want to remind you guys, when you see a structural formula, it's going to take all of those, it's going to be all of those atoms, which are represented by letters, connected with lines, which represent bonds. So I'll show you the structural formula for a carbohydrate. Sucrose. Oh, is that going to be backwards when you guys see it? Oh, well, it probably doesn't matter. So it looks backwards to me. I don't know if it's going to be backwards to you. But anyway, sucrose. So sucrose is a molecule. It's a carbohydrate made of 2 rings, and that's a way that you can identify, number 15, a carbohydrate molecule written in a structural formula. This has 2 rings. This ring is glucose, simply put, because it's a hexagon, okay? And this is fructose. So basically, sucrose is made of a glucose molecule bonded to a fructose molecule, okay? And you might recognize sucrose. You might have it in your kitchen. Looks like this. It's sugar. Yeah. So the molecules that make up this sugar right here look like this, if you were to look at them under a special kind of microscope. All right. Number 16 says, draw the following. You're going to draw a monosaccharide, a disaccharide, and a polysaccharide. So for this one, I drew it for you. So I'm just going to put it up there. And you can, if you can have the sub, please pause the video here so everyone could draw it really quickly. And unpause. So basically, you have hexagons here, and the prefix mono means 1, and so that means 1 ring. And the prefix di means 2. That means 2 sugar rings. Saccharide means sugar. And the prefix poly means many. So that'd be like 3 or more rings. So polysaccharide, many rings. Disaccharide, 2 rings. Monosaccharide, 1 ring. And these don't have to be hexagons. They don't have to be glucose. They could also be pentagons. So, or other shapes. But most common, glucose. All right. So now we're on to lipids. A lipid is and I want you to put fat or oil. I know there's only one spot there, but I want you to put lipid is a fat or oil. Again, that's for your 17. So you had lipid is a fat or oil. 18, lipids are mainly used to store energy. Okay, so 18 is store. Now you might already know that animals that hibernate need to get a lot of fat. They need to accumulate a lot of fat throughout the summer and the fall. And the reason why is so when they hibernate, they can use all of that fat to keep their metabolic processes going so they don't die while they're trying to hibernate. Okay? So that's an example of how lipids are used to store energy. Also, if you eat a lot of food with a lot of fat in it, your body can be like, oh, well, we have all of this extra energy now. And even if you eat a lot of food with a lot of sugar in it, extra calories, basically. And you guys know this is basic, right? If you eat a lot of extra calories, your body is going to say, wow, we have the extra energy now, but maybe later there'll be a famine. You never know. So what they're going to do with those extra calories, even if they're sugar molecules, they will convert them through metabolic processes to fat molecules, and then they'll store them, and then your pants will stop fitting. Accumulation of lipids. All right, so 19. Why are lipids important parts of cell membrane? So I'm going to introduce you guys to the phospholipid. This is a type of lipid that makes up cell membranes. All right. So the phospholipid is made of 2 fatty acid tails and 1 phosphate group. I show it with a circle, but really all a phosphate group is, you guys know phosphate is a type of atom, right? Remember, it's on the periodic table of elements. So all a phosphate group is it's just a group of atoms with a P in it, and the P stands for the phosphate. Okay? Just think of it that way. The whole thing together is called a phospholipid. Okay? These are very important because they make up cell membranes. So the other picture was Allie. Shh. So the other picture was a phosphate group and then 2 fatty acid tails. This is how they orient themselves in a cell membrane. Okay, and remember that the cell membrane is just the thing that surrounds the cell. All right, we'll talk a lot more about that later. This is kind of just an intro to it. So the answer to 19, why are lipids important parts of cell membranes? Because that's what cell membranes are made of. So write that down for 19, because that's what cell membranes are made of. Let me just scroll here. Okay, so we should all be on page 5 now. If you missed some answers, please don't shout out, wait, what's the answer to 19 or 18? Please just stay with us as a class and go back to that and ask your friend later. Okay, so right now, you should be on page 5. All right, number 20 says many lipids form when a glycerol molecule combines with 3 fatty acids. Okay, and the fatty acids are just those long chains of carbon. So here, when I showed you the phospholipid, these lines right here are the fatty acid tails. Okay, so these are fatty acids, and we call them fatty acid tails. Okay, now the molecule we're talking about in number 20, 3 fatty acid tails combined to a glycerol. That is, and you'll probably recognize this from the Amoeba Sisters video, they're actually talking about a triglyceride. Looks like that. Okay, so if you look at it, this is your glycerol molecule, these 3 carbons and the O's, and these are your fatty acids. Okay, you have 1, 2, 3 fatty acids. And again, just pointing out, it's in the shape of an E, so it's pretty easy to figure out if you're looking at this structural formula or another one. Okay. And then it says draw the lipid molecule with 3 fatty acids and a glycerol. Again, draw this shape only. So what you guys are going to do is you're just going to draw the E shape. There's not a lot of room there, and it doesn't matter. Just draw an E. Let me ask you, capital E or lowercase e? Uppercase E, capital. Okay. Now, one thing I want to point out is these fatty acids are different. You have 3 of them. One of them is different than the others. It's this one right here. It's all about the presence of that double bond right there. So we talked about the double bond before. It's just literally when the atom is bonded twice to something instead of just once. The double bond changes a lot of things about the fatty acid, but basically to identify it, we just say it's a fatty acid with a double bond. So 22 says define saturated lipid. If it's saturated, it's not going to have any double bonds. So what you'll write for that is a fatty acid without double bonds for 22. Or you can just write for 22, you can just write no double bonds. Okay? So again, that's your 22, right? No double bonds. Then for 23, you'll write at least one double bond. And some of you guys might be a little confused because you see the double bonds here. So we're not talking about the double bonds up here. We're talking about the ones actually in the chain, okay? There are no double bonds here or here within the chain, okay? But there is one here. So this guy is unsaturated, and you would write has at least one double bond. And these are saturated, do not have any double bonds, okay? All right, moving on to nucleic acids. 24, you don't need to write anything for. It says nucleic acids are macromolecules that contain hydrogen, oxygen, nitrogen, carbon, and phosphorus. So they're the CHOMP, remember? 25, stop. 25, nucleic acids store and transmit hereditary information in the form of DNA and RNA. So that's what you're writing for 25, not the A and B. For the first one there, again, I'm going to say it. 25, nucleic acids store and transmit hereditary information in the form of DNA and RNA. Okay. And then A and B, it says blank stores hereditary information and blank transmits hereditary information. So DNA is the one that stores hereditary information. It's a sedimentary molecule. It's a sedimentary molecule. It just it stays in one place, and then RNA transmits hereditary information, so that one moves. Okay. So that's your 25, A and B. DNA first, then RNA for A and B. And then 26, nucleic acids are polymers. So poly, P-O-L-Y-M-E-R-S, made of monomers called nucleotides. Okay. And, okay, hold on. I'm going to have to stop this because my daughter just woke up. So we'll pick back up at 26.